You're welcome.
Hey, David. Oh,
Yep.
hey,
You
David.
hear me?
Yeah, I think it will just be you and me. Maybe Mark will join. I don't know.
Yeah, let's give everybody a couple of minutes.
Yeah. So JP mentioned he can't make it today.
Okay.
David, do you happen to have the slides that were presented by Business Workstream this morning?
I do not know.
Okay. Okay, I think it's just going to be you and me. And maybe then we can just wrap up the meeting sooner. So,
Yeah.
last week we were thinking about those three options, right? One was to take some of the work that's in the demo design meeting from CDX and actually extend it to some system level proof of concept, right? Not just the modeling, um, not just the modeling piece of it, which or the workflows, right? And
Yes.
the other one was, do we go after golden chiplet? Unless until there's somebody driving that, I think that would be a bit of a difficult thing, right? Or so
Yeah.
so should we talk a little bit more about the system level modeling,
Um.
especially in the context of what was being discussed this morning? Is there some intersection?
Um. Let me get my thoughts in order. Yeah, I think there is an intersection. I think there is. I do see a lot of interest in. That's a common question that's asked is how they make these different chips work together. So I think the effort by the business group to drive that, I think that's a very good thing. The question is how would that work? And to be honest, I'm not sure.
So let's just do a thought exercise. Okay, so um, what these guys were talking about today is front end, right? Primarily front end models, and maybe those can be pieced together to do some power performance area modeling. Challenge is people generally feel uncomfortable providing that level of detail, right?
That's right.
Is there
And,
some wrapper mechanism that can be used there?
um, I'm not sure maybe there is, um, but system C models are whenever they exist, I think of them at the level of right, they're proprietary models, and they're
Mm.
at the same level as RTL, if not even higher, right? Because system C, you can make quick changes to the system C and actually spin off a brand new chip, something that may be a little bit more difficult in RTL, right? So as far as I know, all the tools require that all the models be present and they get compiled and they work.
David, some time ago, there used to be these encrypted Verilog model that IP companies would provide. Do you remember that?
Yes,
Now, I don't know how good the encryption is and what is the current status of all of that technology. Um, is it feasible that something like that might work?
but these are going to be encrypted models that everybody will have access to, right? So so here's the thing about encrypted Verilog, right? You do get encrypted Verilog that you can run RTL verification on. You can also synthesize it to a netlist, to a gate level netlist, right? So the encryption is only at just up to some point, right? At some point, you are able to synthesize a netlist, and you get your private key and all that, right? So uh, the thing with the key is, right, if you want to give it to the world to test your chiplet, and you give the key to decrypt that model, that means anybody can access it and then synthesize it. That's the difficulty with all of this. There has to be another high level of access control that wraps everything, so that you cannot extract the model, you cannot do nefarious things with it. You can only run simulation, pretty much.
Do you know who defines that encryption methodology or protocol?
I think IEEE is defining it for RTL.
I see. But IEEE doesn't do jack shit themselves, so they must have done it for somebody else.
Yes,
And who did they do it for?
I don't
And
know. I don't know.
but this thing is like been there forever, no?
Yeah, it has been there forever. Yes.
Right? And the beneficiaries that I have seen of this encryption are people who are supplying IP,
Yes.
right? So they have some level of, because what they do is they just give that model only to their paying customer, and paying customer can then synthesize it.
That's right.
Now what we are talking about is the world of chiplets, right? Enabling a commercial transaction,
Yes.
helping with that. You know, maybe this is a thing to be addressed in the business work stream, right?
Yep.
That unless until this concern is addressed, people will have really hard time using any proposal that OCP may have.
That's right. And um even being able to run a simulation against a model, um I'm not sure if everybody would be willing to do that, right? Because your competitors could run simulations against your model, And right, if me and you are competing, I'll run simulations against your model, and I'll make sure my chip works better, and I'll have slides to show to my customers that my IP works better than yours, right?
Yeah.
So, right, how would me and you sit on the same table and provide the same information, right?
Yeah. And the thing is, last time when I spoke with OCP to actually have something more detailed on in the marketplace, which would be, say, a net list of some kind. OCP is not set up to guarantee anyone's data integrity or privacy, or they don't want to take any of that risk,
That's right.
right? They
Yeah.
will happily advertise somebody else who may come up with this platform of providing access control so others can be put into a marketplace and do the interoperability.
Yeah.
Okay, but let's imagine that we solve this problem. Let's imagine that there is a solution that, and then somehow the industry is willing to use this OCP platform. What next?
Let me think for a moment. So what you're saying is there's a platform where somehow privacy and privacy is guaranteed and access controls are in place, right?
Yep. Please remember the diagram this morning. There was a green box in the middle, right? That has all the models. And then there are boxes outside of it that are basically emulators and simulators, right? And you can do the modeling, soft modeling using these high level views, or you can do an FPGA modeling also, right? That's what the diagram shows.
Yeah.
So the big question is, what emulator, what simulator, how does that whole thing work? Is that something that OCP does, or is that something that outside people do? What's the idea?
This is something that outside people will have to do, right? Because if you're talking about right models, we are talking about vectors to drive those models, right? So if there is an accelerator module and you want to run transactions against that, you have to have the model to run against it, right? Which means somebody will have to set up the connectivity, somebody will have to set up the vectors and run it and see the performance of that. Right. So somebody will definitely have to be sitting outside, right? And collating these models into a system and run something against it. Right.
Yeah. Mhm.
So meaning I have to have an actual design in mind that I'm ready to start designing.
Right.
And I have kind of made up my mind what it's going to do, and I just need to drive vectors, right? There's a lot of complication that comes from this, which I don't know how this will work. Is all these chiplets? Is a chiplet is pretty much everyone is most of them. Let's say you're going to have some CPU in it that will have to run code, right? If you want that. CPU to dispatch loads and drive all the accelerators, there has to be some code for that. So somebody will have to even write a code for it.
Right.
Right. So yeah, regulator can run system C, but you have to you have to write a C program that you compile into, right? Let's take, for example, RISC-V, right? You can create a system C model out of the RTL, but to run it, you have to write a code to do something.
Right. I mean,
Then you, right?
historically, when we did emulation on CPUs, it was bring up the model and boot Linux.
Yeah.
Right. That would be the very first thing. And some more dating ones booted Windows, and they were playing Doom on it. Right. Something like that.
Yes.
But
Yeah.
there's no
We did same thing with RISC-V sometime back in SA2. Just instead of booting Linux, there were special programs. There was actually a test suite that will exercise different instructions and the performance of different instructions. And you'll see the pipeline stalls, things like that, right? Cache line weights and all that stuff, right? But there is a code that is running. So meaning, okay, so let's say I wanted to build a system that has a CPU chiplets together, right? I still have to write the code for it and see how it behaves.
Yeah.
Yeah, so right, the key here is I get the idea, but they're very difficult how questions to answer.
Right.
I think we need a bigger group to brainstorm on this.
I mean, that's a given.
Yeah.
Right. But I think there's one commercial challenge, which is a market to seed a marketplace. You need people to contribute these models, right?
Yes. Yep.
I think that's pretty much it, right? People contribute models, and models are available in a centralized location, and there is some way that they can maybe just license the simulation models to do simulation. And then there is some kind of a workflow set up for actual modeling, right? So this is a interesting path for industry. I think what POC group can do is to primarily do an example, right? We can actually do a proof of concept and show that technically this thing is feasible.
Yeah.
But with some experience on this thing from my past, this is a very labor intensive work. Not sure if volunteers will be able to do it, even for the
Yep.
POC, right?
Yeah. Yep.
So, but maybe if some big companies jump in, maybe there's a path.
Yes.
Say somebody like AMD or IBM likes it, and they contribute some resources, is possible,
Yep.
right? Okay, I think this is good discussion, David.
Yeah.
So nobody's here. I think we can just hang up
Yep.
and maybe I'll talk to JP and see.
Yeah. We need a bigger group to brainstorm about this.
Right.
Yeah.
Okay, David.
Roger. Talk to you later.
Thank
Have a
you.
nice holiday.
I'm gonna hang up. Bye.
Bye.